Welcome back to the Deep Dive. Today is Thursday, February 26, 2026. And I have to say, looking at this massive stack of papers you brought into the studio today, I was getting a little bit of deja vu.
Oh, yeah. How so?
Well, not because we've actually covered this exact topic before, but because the headline on the main report, it's called The Psychology of Loneliness.
Right.
And it just feels like something we would have seen in a glossy magazine way back in like 2015. It sounds very, I don't know, soft.
Yeah, atmospheric.
Exactly. But then I looked at the subheader, which is how social isolation physically changes the human brain. And then I saw the source, which is the Global Institute for Neuroarchitecture.
Which is definitely not a lifestyle magazine.
No, not at all. And that really threw me. Because I think, we hear the word loneliness and we instantly think of poetry or sad blues songs or just that sort of gloomy feeling you get on a rainy Sunday.
That is the exact trap everyone falls into. We think of it as just a fleeting emotion. But the reason we're doing this deep dive today is because the scientific consensus has fundamentally completely shifted.
And this report is sort of the culmination of that shift.
It is. This was just released this morning.
Yeah.
And it is essentially the capstone on 5 years of incredibly intense biological research.
It's just wild to think about how much the conversation around this has changed just since the mid-2020s. I mean, for those of you listening, we all remember the post-pandemic years, the whole Great Resignation era, the Great Detachment.
Right, the mental health crisis was front-page news every day.
We talked about mental health constantly, but reading through this data you brought, it feels like we were spending all our time talking about the symptoms while completely ignoring the actual disease.
Or at least ignoring the physical mechanism of the disease.
Yeah.
That's a very fair assessment.
Yeah.
If you look at the medical literature from even just 10 years ago, loneliness was always treated as a proxy for something else. It was a proxy for depression or a secondary symptom of anxiety.
It was just a feeling.
Exactly. It was subjective. But the massive shift we are looking at now, here in 2026, is that loneliness is no longer classified as an emotion in these high-level neurobiological circles.
What is it classified as, then?
It is a biological signal, and importantly, in its chronic form, it is now classified as a pathogen.
A pathogen? I mean, that is a heavy word. That's a word we usually reserve for viruses or bacteria.
It is.
Something that actively invades and destroys. Are you saying isolation acts the exact same way?
The hard data suggests yes. Think about what a pathogen does. It invades the system, it disrupts its normal function, and it causes damage.
Okay.
What we now know, and what we're going to unpack for you today, is that chronic social isolation physically remodels the architecture of your brain.
It actually eats away at neural tissue.
It does. It alters the way your genes express themselves. It literally changes the chemical composition of your blood. It's a full-scale systemic assault on the body.
Which is terrifying, honestly.
It can sound that way, yeah.
Because I think most of us operate under this assumption that our brains or these static, sturdy organs inside our skulls, and our feelings are just sort of clouds passing over a mountain.
I like that analogy.
But this report is essentially saying the clouds can actually dissolve the mountain.
In a very real way, yes. But I do want to reframe this right away. The mission of this deep dive isn't to terrify people listening. It's actually to validate them.
Validate them how?
Because for decades, people who struggled with deep chronic loneliness were told by society to just get out more or, join a local club.
Right, like it was just a behavioral quirk they needed to snap out of.
Exactly. It was treated like a character flaw. But when you understand the biology, when you realize that your brain has been forced into a hypervigilant self-preservation mode, a mode that makes connection physically difficult, it changes the treatment paradigm entirely.
It stops being a personality issue and starts being a recognized medical condition.
Exactly.
Yeah.
It's a necessary evolution in our medical understanding, very similar to how we eventually realized physical stress causes heart attacks. We used to think stress was just in your head, too.
Wow. Okay, so let's get into the actual mechanics of this, because the report is incredibly dense. I mean, I was looking through charts on gene transcription and fMRI scans of the brainstem and all these immunological assays.
It's a lot of data.
It is, but it does seem to follow a very logical, almost chronological journey. It starts with the why. Why do we even have this biological signal in the first place?
To understand the why, we have to start with the evolutionary imperative. We have to talk about this concept of social hunger.
Okay, social hunger. I've heard this term floating around the pop science sphere for a bit, but this report treats it as a hard, measurable biological metric.
It absolutely is. So let's break it down. You have a biological signal for a caloric deficit, right?
And we call it hunger.
Exactly. When your blood sugar drops, Your stomach produces a hormone called ghrelin. It travels up to your brain, and you feel a very specific, highly unpleasant sensation.
A sensation that compels you to go open the fridge and find food.
Right. It's a survival mechanism. It physically hurts so you don't starve to death.
Okay, that makes sense.
Now, I want you to rewind 2 million years. You are an early hominid out on the savannah. What is the single biggest, most immediate threat to your survival?
Well, not starvation if we're comparing it to hunger. I'm guessing predators.
Starvation, yes.
Yeah.
And exposure to the elements.
Yeah.
If you are separated from your tribe, your life expectancy out there drops to hours, maybe a couple of days at most.
Because you literally can't sleep. You'd have to watch your own back 24/7.
Precisely. You have no one to share watches with, no one to help you hunt, no defense. Exclusion from the group was a literal death sentence.
Okay.
So nature and evolution had to solve a very specific problem. How do I ensure this individual, who has free will and can wander off, chooses to stay with the group?
Even when the group is being annoying.
Right. Even when you have to share your hard-earned food or deal with tribal politics, nature had to hardwire a mechanism to make isolation feel physically intolerable.
So it basically repurposed the pain circuitry in our brains.
It did exactly that. And this is where the new 2026 data from the Center for Social Neural Networks is just so incredibly compelling.
The fMRI studies.
Yes, they did a series of comparative neuroimaging studies. They took human subjects, put them in an fMRI machine, and subjected them to physical pain, mostly localized heat stimuli on their arms.
Like touching a hot stove.
Exactly. They mapped the brain's response to that physical tissue damage. Then, they took those same people and subjected them to social pain.
How do you ethically inflict social pain in a lab?
They used exclusion scenarios. They had them play virtual games where the other players suddenly start ignoring them and passing the ball to everyone else. They showed them images of ex-partners who rejected them.
Oh, that is brutal.
It is. But the brain scans from those two different types of pain.
They look the same.
The overlap was absolutely shocking, specifically in a region called the anterior cingulate cortex.
Okay, what does that part of the brain do exactly?
It's the part that registers the emotional unpleasantness of pain. It's not the part that says, ouch, my arm is hot. It's the part that processes the suffering aspect, the distress.
Wow.
The human brain uses the exact same neural hardware, the same circuitry, to process a broken leg as it does to process a broken heart or social rejection.
Which perfectly explains why we rely so heavily on physical metaphors when we talk about being rejected.
Right.
We say things like, it was a slap in the face, or I was crushed, or it literally broke me. We aren't just being poetic writers.
No, we are being incredibly literal. We are simply reporting exactly what our anterior cingulate cortex is feeling in that moment.
That is fascinating.
But the social hunger concept goes even deeper than just registering pain. It's fundamentally about
Craving connection.
Yes. When you are isolated, your midbrain lights up on these scans in the exact same way a drug addict's brain lights up when they are shown drug paraphernalia, or a starving person being shown a massive burger.
It's a primal drive state.
It is a profound biological drive state.
But wait, here's the paradox that I always struggle with when I read about this. If the drive is really that strong, if our bodies are biologically screaming for connection, why do lonely people so often withdraw?
That is the big question.
Because if I'm hungry, I don't hide from food, I eat. But if I'm lonely, I'm highly likely to pull the blankets over my head, cancel my plans, and ignore all my text messages.
And that right there is the crux of the entire issue. That is the exact pivot point where acute loneliness, which is actually a healthy functional signal, transitions into chronic loneliness, which is toxic and destructive.
Okay, walk me through that transition.
To understand it, we have to look deep into the brainstem. We have to talk about a very specific cluster of cells called the Dorsal Raphe Nucleus.
Yes, the DRN. I made a huge circle around this entire section in the report because I had never heard of it in this context before.
I'm not surprised.
I always thought the DRN was mostly involved in, like, sleep cycles and mood.
For a very long time, so did most neuroscientists. It's a relatively tiny cluster of neurons, roughly 30,000 of them, sitting way down deep in the primitive brainstem.
So it's evolutionarily very ancient hardware.
Exactly. And we've known for decades it was the primary source of serotonin for the forebrain. So naturally, we linked it to mood regulation and sleep-wake cycles.
But this new research changes that.
It expands it massively. This new data shows the DRN actually acts as a sort of biological social stopwatch.
A stopwatch, meaning it's physically tracking time.
It is tracking the specific interval of time since your last meaningful social interaction. It's fascinatingly
How did
precise.
they figure that out?
They used mouse models. And we can confidently extrapolate this to humans given how conserved this brain structure is across mammals. In the study cited in the report, when a subject is in a group, playing and socializing, the DRN is relatively quiet.
It's just hanging out in the background.
Right. It's in a calm baseline state.
Okay, so when I'm hanging out with my friends on a Friday night, my DRN is just chilling.
Correct. But the very moment you are isolated, the moment the group leaves, that biological stopwatch clicks on. It starts ticking.
And what happens in the brain?
The neurons in the DRN begin to fire. And as the hours of isolation persist into days, they fire faster, they become hyperactive.
So the ticking gets louder.
Yes, they enter the state of extreme excitability. And that triggers a massive release of corticotropin-releasing factor throughout the brain.
Which is basically a major stress signal, right?
Exactly. It's an alarm bell.
So it's an alarm clock that just gets progressively louder the longer you let it ring.
That's a perfect way to visualize it. And this is exactly where the withdrawal paradox you mentioned earlier comes into play.
Because initially, that alarm is a good thing.
Right. Initially, that alarm is meant to motivate you. It's screaming, go find the tribe, you're in danger.
But what if you can't find the tribe?
Exactly.
Yeah.
Let's say you're naturally very socially awkward, or you just moved to a brand new city where you know no one, or, there's a global pandemic.
The alarm just keeps ringing.
It keeps ringing, and a human brain cannot biologically sustain a high alert DEFCON 1 alarm state indefinitely. It's too metabolically expensive.
So what does it do? Does it just burn out?
It shifts its entire survival strategy. The DRN, when it's hyperactive for way too long, triggers a massive cascade of structural changes in the downstream areas of the brain.
It essentially gives up on finding people.
It basically says, okay, clearly we aren't getting back to the safety of the tribe anytime soon. The environment out here is hostile. We need to hunker down and prepare for a long siege.
Wow. So the withdrawal, the ignoring texts, staying in bed, isn't a failure of your drive to connect. It's an active defensive strategy by your brain.
Exactly. It's a profound shift in neural operating modes. You switch from seek reward to avoid threat.
That makes so much sense.
But that shift has a terrible cost. It causes actual physical damage to the brain's highest executive centers. Which brings us to the structural decay section of the report.
This is the part of the reading that genuinely unnerved me. Because we aren't just talking about chemicals anymore, we're talking about the physical shrinking of the prefrontal cortex and the hippocampus.
Yes.
In my notes here, to help me visualize it, I called the prefrontal cortex the CEO and the hippocampus the librarian.
That is a highly accurate and very useful analogy.
Yeah.
Let's look at the CEO first, the prefrontal cortex, or PFC.
This is the area right behind the forehead, right?
Yes. Evolutionarily speaking, it's the newest part of the human brain. It is responsible for all our high-level stuff: executive function, impulse control, complex planning, and emotional regulation.
It's the adult in the room.
It is absolutely the adult in the room.
Right.
It exerts what we call top-down control over the rest of the brain.
Give me an example of how that works in real life.
Okay, let's say you hear a loud, sudden bang outside your window. Your amygdala, which is the primitive fear center, basically a panicked toddler, freaks out. It thinks it's a gunshot.
It spikes your heart rate immediately.
Right. But a fraction of a second later, your CEO, the PFC, analyzes the context. It looks at the situation and says, relax, a garbage truck just dropped a dumpster. It wasn't a gunshot.
So the CEO pumps the brakes on the panic.
Exactly. It provides the brakes.
Sure.
But the report clearly shows that chronic loneliness damages those brakes.
And when you say damages, you mean it causes actual physical atrophy?
Yes. The longitudinal studies in this report, which are incredibly robust, tracking thousands of participants over a 5-year period, showed a very measurable, undeniable reduction in gray matter volume in the PFC of chronically lonely individuals.
Gray matter is basically the actual cell bodies of the neurons, right?
Sure.
The processors. So
That's
these
it.
people are literally losing processing power in their brain's executive suite.
You are losing synaptic density. The vital connections between the neurons are literally withering away. Think of it like a bustling corporate office where the staff is slowly, one by one, quitting.
And the CEO is just left sitting there alone, becoming less and less effective.
Precisely.
Yeah.
So let's apply this to a hypothetical person to make it concrete. Let's call him Elias.
Okay, poor Elias.
Elias has been severely isolated for 6 months. His DRN stopwatch alarm has been blaring nonstop. His brain is in siege mode, and his PFC is actively shrinking. What does Elias look like from the outside to his coworkers or family?
Well, if he's losing his emotional brakes, it probably looks like massive emotional dysregulation.
Exactly. Because the CEO can no longer effectively inhibit the panic toddler of the amygdala. Elias becomes incredibly moody.
He might be quick to anger over tiny things.
Right, he might snap at a cashier.
Yeah.
He might feel totally paralyzed and overwhelmed by very small, mundane decisions. The braking system is worn out, so he is just careening wildly through his emotional life.
And the tragic part is people looking at Elias probably just think, man, he's become such a jerk lately. No wonder he's all alone.
Exactly. The biological damage manifests as off-putting behavior, which just reinforces the social isolation. It pushes people further away.
Which accelerates the decay.
It does, but unfortunately it gets even worse. Because while the CEO is struggling to maintain control, the librarian, the hippocampus, is also under a massive chemical attack.
Okay, let's talk about the librarian. The hippocampus primarily handles memory and context, right?
Yes, it is absolutely crucial for spatial navigation and for storing new episodic memories. It's the part of the brain that puts your daily life into a coherent narrative context.
So how does isolation hurt the librarian?
Well, remember that screaming DRN alarm? When it goes off, it triggers the adrenal glands to release massive amounts of cortisol into the bloodstream.
Cortisol being the body's primary stress hormone.
Right. Now, the hippocampus happens to be incredibly sensitive to cortisol. Its surface is just absolutely covered in glucocorticoid receptors.
So it absorbs the brunt of that systemic stress more than other parts of the brain.
It acts almost like a sponge for it. And chronically high levels of cortisol are highly neurotoxic to the delicate tissue of the hippocampus. Most notably, they severely inhibit a process called neurogenesis.
Which is the birth of brand new neurons.
Yes. Now, we used to think, decades ago, that the human brain stopped growing new cells once you reached adulthood. But we know now that the hippocampus continues to generate fresh neurons throughout your entire life.
Unless you are chronically stressed out.
Exactly. If the cortisol stays high, that neurogenesis production line just completely shuts down.
Wow. But reading the report, it mentioned something even more specific and frankly more disturbing than just stopping new growth. It talked about the pruning of existing cells.
Yes, this is the active destruction of dendritic spines.
What does that mean visually?
Imagine a lush, healthy tree in the middle of summer. Then imagine that same tree in the dead of winter. The main trunk is still there, but all the fine, delicate branches, the dendrites, have been stripped completely bare.
And those branches are important because...
Because those branches are where the synapses live. That is the exact location where information is exchanged between brain cells.
So if Elias' branches are being pruned back by cortisol, he isn't just moody, he's becoming cognitively foggy.
He is severely cognitively compromised. He starts having trouble focusing on tasks at work. He has trouble remembering where he put his keys or recalling what someone told him just last Tuesday.
He's living in a haze.
He feels a profound sense of confusion. And think about how deeply terrifying that is for him.
Yeah.
You are already completely alone. Your brain is telling you you're under constant threat. And now you can't even trust your own memory to hold on to basic information.
It sounds like an inescapable downward spiral. The biological changes make it harder and harder to successfully navigate the social world, which naturally leads to more isolation, which then just triggers more biological damage.
It is a devastating, self-reinforcing feedback loop. But what is truly critical for you to understand is that this destruction doesn't just stay neatly contained inside the skull.
It spreads.
The brain is just the command center. The body is the soldier taking the orders. And if the command center is constantly broadcasting, we are alone, we are under siege, the soldier prepares for all-out war.
Which brings us to the next major section of the report, on systemic inflammation. The body at war.
Yes.
This was the part where I felt like the use of the word pathogen really started to make total sense to me. Because we are now talking about the human immune system turning on itself.
We are. And honestly, this is the area where the science has advanced most rapidly just in the last 2 or 3 years. We used to look at inflammation as a purely localized response.
Like you accidentally cut your finger chopping vegetables and it swells up and gets red.
Right, localized healing.
Right.
But we now understand this systemic phenomenon called the conserved transcriptional response to adversity, or CTRA for short.
Okay, that is a massive scientific mouthful. Let's break CTRA down for everyone. Transcriptional response means we are talking about gene expression at the cellular level.
Yes. We tend to think of our DNA as this rigid, fixed blueprint that never changes. And while the actual sequence of letters doesn't change, the expression, meaning which specific genes are turned on or turned off at any given moment, is highly dynamic.
It adapts to what's happening to you.
It changes constantly based on your environment. The CTRA is an ancient, hardwired genetic program that boots up whenever the body perceives profound adversity or threat.
And chronic isolation triggers this genetic program.
It triggers it aggressively. When the brain registers the state of "I am alone," the CTRA flips a very specific set of genetic switches inside your immune cells.
What happens when the switches flip?
First, it drastically upregulates pro-inflammatory genes. It prompts your white blood cells to start pumping out massive amounts of cytokines, specifically these markers called interleukin-6 and TNF-alpha.
Okay, but why? This is what I couldn't wrap my head around. Why would just being lonely make my body want to be physically inflamed?
Again, you have to think back to the early hominid on the savanna. If you are entirely alone out there, what is the most statistically likely cause of your impending death?
Well, like we said earlier, a predator.
Right. It's physical trauma. It's a tiger scratch, a wolf bite, a broken bone from a fall. And all of those physical traumas instantly introduce deadly bacteria into your bloodstream.
Oh, I see.
So the body preemptively floods your entire system with systemic inflammation to prepare to fight off potential bacterial infections from the wound you are almost certainly about to receive.
It is literally preparing your flesh for a physical wound that hasn't happened yet.
Exactly.
That is incredibly smart for a caveman.
It is absolute flawless brilliance for a caveman who might be mauled tomorrow. But there is a massive biological trade-off. Because the body's energy is finite. When the CTRA upregulates that heavy inflammation, it has to downregulate something else to compensate.
What does it turn off?
The antiviral response.
Wait, it actively turns down your viral defenses?
Yes, it drops your antiviral shields. Because think about how viruses usually spread.
Through close social contact, coughing on each other, sharing space.
Exactly. If you are completely alone in the wilderness, you are highly unlikely to catch the flu from someone. You are much more likely to get eaten by a lion. So the body prioritizes the antibacterial defense over the antiviral defense.
But we don't live on the savannah anymore. Our guy Elias lives alone in a modern apartment complex. He is not going to get eaten by a lion while watching Netflix.
And that is the crux of the evolutionary mismatch we are suffering from today. Elias is sitting safely on his couch, physically perfectly secure. But his genetic code is pumping out inflammatory cytokines as if he's about to be torn apart by wild animals.
And his viral defenses are down.
Yes. This is exactly why decades of epidemiological data show lonely people are significantly more susceptible to seasonal flus and respiratory viruses.
Because their shields are literally powered down.
Right. And more insidiously, this chronic low-grade inflammation is the root fuel for a host of modern diseases. This is why chronically isolated populations have drastically higher rates of autoimmune disorders, cardiovascular disease, type 2 diabetes, and even metastatic cancer.
It's just burning out the system.
It also aggressively accelerates biological aging. The report details how telomeres, the little protective caps on the ends of your chromosomes, erode much faster in lonely people due to this constant inflammatory state.
It's basically like revving the engine of a car into the red line while it's just parked inside a closed garage. You aren't going anywhere, you're just filling the entire room with toxic exhaust.
That is a perfect analogy. And the truly scary part is that exhaust, those circulating cytokines, they don't just stay in your body, they eventually travel back up to the brain.
Which leads us to the 2026 findings from Johns Hopkins. The part of the report regarding the blood-brain barrier.
Yes.
I called this part the fortress wall in my notes. This visual really drove home the physical damage for me.
The blood-brain barrier, or BBB, is an absolute miracle of biological engineering. It's a highly selective lining of endothelial cells inside the brain's blood vessels. And these cells are stitched tightly together by what we literally call tight junctions.
They act like a filter.
Better than a filter. It's designed to be highly impermeable. It keeps all the chaotic chemistry and immune battles of the bloodstream far away from your very delicate neural tissue.
So it's essentially the bouncer at the club, keeping the riffraff out of the VIP section.
The ultimate bouncer. But systemic inflammation over time acts like a bribe to that bouncer. The inflammatory cytokines constantly circulating in the blood actually start to attack those tight junctions.
The stitches holding the wall together.
Right. They cause them to physically loosen and degrade.
So the fortress wall actually becomes leaky.
It becomes dangerously permeable. In neurology, we call it leaky brain.
What happens when it leaks?
Things that should never, ever touch. Brain tissue, neurotoxins, rogue immune cells, heavy inflammatory markers start to slowly seep through the wall and into the brain itself.
And when they get in there, what do they do to the neurons?
They inflame the brain itself. We call this neuroinflammation.
Yeah.
It directly attacks the neural networks. It massively exacerbates the brain fog, the deep depression, the overwhelming lethargy that lonely people feel.
It's just a total system failure from the genes to the blood to the brain, all initiated by one simple social signal.
Yes.
It's overwhelming to think about. I mean, we've gone from a simple, relatable feeling of, hey, I miss my friends, to a hardwired genetic switch, to massive systemic inflammation, to a literally breached brain barrier.
It really reframes the whole human experience, doesn't it?
It makes you realize just how deeply integrated we are as a species. We aren't really solitary individuals at all. We are biological pieces of a larger organism. And when we detach from that organism, we just begin to decay.
That is the profound philosophical truth living underneath all this hard biological data.
But there is actually one more layer to this tragedy before we get to the hope and the recovery phase. And that layer is perception.
The distortion of reality.
Right, because Elias, sitting there on his couch with his leaky brain and his inflamed immune system, he doesn't just feel physically bad. He actually sees the physical world differently than a connected person does.
This is the cognitive distortion phase.
Yeah.
And honestly, from a clinical perspective, this is often the hardest part to treat because the patient has absolutely no idea it's happening to them. They think they are seeing reality clearly.
The report calls this the neutral face bias. Can we walk through this concept? Because I found it mind-blowing. Let's take our guy Elias to a local coffee shop.
Okay, let's do that. Elias finally forces himself to leave his apartment. He walks into a busy local coffee shop. He steps up to the counter and looks at the barista.
Okay.
Now, the barista's busy. She's focused on steaming milk for a latte. Her face is totally neutral. She's not smiling warmly, but she's not frowning or angry either. She's just blank. Concentrating.
Right, just a normal person doing a job.
Yeah. Now, if you highly socially connected person with a healthy brain walk in and look at her, your brain registers a neutral phase. You might think, oh, she's concentrating. Or, more likely, you don't think anything about her expression at all.
It doesn't trigger any alarm.
Exactly. But Elias, his brain has been remodeled, his amygdala is hyperactive, and his PFC brakes are broken. His threat detection system is calibrated to maximum paranoid sensitivity.
So what does he see?
When his eyes process that neutral face, his brain physically refuses to register it as neutral. It forcefully registers it as hostile.
Wait, he literally hallucinates a threat. He sees a frown or an angry glare where there objectively isn't one.
The visual processing centers interpret the ambiguity of a blank face as a direct threat. His internal narrative immediately becomes, she is mad at me, she thinks I'm weird, she is judging me and wants me to leave right now.
That is heartbreaking. So he obviously acts weird in response. He gets super defensive. He probably mumbles his order, avoids all eye contact, maybe acts a little rude because he feels attacked.
Exactly. And how does the barista react to a customer being weird and rude? She becomes uncomfortable. So now maybe she actually does frown, or she becomes very short and cold with him.
And Elias walks out with his coffee thinking, see, I knew it. Everyone hates me. I'm never leaving my apartment again.
It is the ultimate self-fulfilling prophecy, and this isn't just a theory. The eye-tracking studies that are detailed in the report completely confirm this physical mechanism.
How did they test that?
They put subjects in a lab and showed them complex images of large crowds of people. Highly connected people naturally scan faces, looking for eyes and looking for smiles. They are subconsciously searching for signs of social reward and connection.
And the lonely subjects.
The lonely subjects don't look at the center of faces. Their eyes dart around, scanning the periphery of the image. They scan for sudden movement. They look for signs of anger or danger. They are not looking for a friend. Their brain is actively searching for an enemy.
Because they're stuck on the savannah looking for lions.
Precisely. And the worst part of this perceptual shift is the parallel atrophy of the theory of mind network. Specifically, an area called the TPJ.
The temporal parietal junction?
Yes. The TPJ is essentially the neural hardware for empathy. It's the region that allows you to effortlessly simulate another person's perspective in your own mind.
Like me thinking, I wonder what the expert is going to say next.
Exactly. That basic ability to model my mind inside your mind requires a healthy TPJ. But just like a physical muscle, if you do not use it,
It atrophies and gets weak.
it degrades significantly. If Elias hasn't had a deep reciprocal conversation in 6 straight months, his TPJ is entirely out of shape.
So even if he genuinely wants to connect with someone, he struggles.
The cognitive load of simply trying to understand what someone else is feeling or thinking becomes exhausting. For a connected person, empathy is automatic and effortless. For Elias, it feels like trying to do complex calculus in his head while running on a treadmill. It's draining.
So he just gives up.
He retreats. It is biologically much easier to just be alone than to do the heavy, painful lifting of empathy with a damaged brain.
Wow. Okay. We have painted a very, very bleak picture here. We have stripped poor Elias down to his inflamed, atrophied, paranoid core.
We have.
But I want to pivot, because we are not just here to announce the doom of humanity. The year is 2026, and the back half of this massive report has an entire section simply titled The Cure.
Yes. And this is exactly where the pathogen model we've been talking about actually becomes incredibly hopeful and helpful.
How so?
Because if we understand that chronic loneliness is a physical biological injury, a remodeling of tissue, then we know we can actively treat it with targeted biological rehabilitation.
And it all hinges on this concept of neuroplasticity.
Exactly. The human brain is highly plastic. It is not poured concrete. Even well into late adulthood, the brain retains the ability to radically rewire and rebuild itself.
So the damage isn't permanent.
We have definitive proof now that the gray matter atrophy in the PFC and the pruning in the hippocampus is physically reversible.
Okay, but how? Because based on everything we just said about Elias's hyperactive amygdala and his neutral face bias, you can't just slap him on the back and tell him to go to a crowded party. That seems like it would spectacularly backfire.
Oh, it would be disastrous. Throwing Elias into a loud, unstructured party would just trigger a massive cortisol spike and a severe stress response. He would panic, flee, and retreat even further into his shell.
So what is the actual clinical approach?
The new, highly successful protocols focus on a technique they are calling social microdosing.
Social microdosing.
Yeah.
I love this term. It sounds very Silicon Valley biohacker, but the underlying logic makes a lot of sense.
It's basically a highly specialized form of exposure therapy. Think about how we treat a severe phobia. If you have a paralyzing fear of spiders, a therapist doesn't just dump a bucket of live tarantulas on your head.
Right, that would cause a heart attack.
They start incredibly small. They show you a drawing of a spider. Then, days later, a plastic spider. Then, maybe a real spider inside a locked glass cage all the way across the room.
You slowly build tolerance. So how do you practically microdose social interaction for someone who is isolated?
The clinical protocol involves very short, highly structured, and entirely predictable interactions. We're talking about maybe 5 to 10 minutes maximum.
Okay.
And it's usually done with a completely safe interlocutor, a trained therapist, or a specialized volunteer who knows exactly how to manage the interaction.
But honestly, 5 minutes? That seems almost trivial. How does 5 minutes fix a physically atrophied brain?
Because it's not actually about the deep content of the conversation. They aren't discussing the meaning of life. It's entirely about manipulating the prediction error inside the amygdala.
Prediction error. Break that down for me.
Elias's damaged amygdala is constantly making a baseline prediction. Social interaction equals pain, humiliation, and rejection.
Right, because of the neutral face bias and the siege mode.
Exactly. So he goes into this highly controlled 5-minute session. He sits down. He talks to the volunteer about the weather or a television show. The volunteer actively smiles, uses warm body language, and maintains a safe environment. The 5 minutes end. Elias goes home.
Nothing bad happened.
Exactly. The amygdala's prediction failed. The brain goes, I was absolutely positive we were going to be attacked and die just now, but we didn't. We survived.
And you just repeat that.
You repeat it again and again and again. And slowly, fractionally, the prediction error forces the brain's alarm system to downregulate. The ticking of the DRN stopwatch starts to quiet down.
And as that alarm quiets down, the stress hormones drop.
The cortisol levels in the blood finally begin to plummet. And the moment the cortisol clears out of the hippocampus, the gardening process begins again.
The librarian gets back to work.
Neurogenesis restarts. Fresh neurons are born. The dendritic spines in the prefrontal cortex slowly start to sprout and regrow. The braking system comes back online. The CEO walks back into the corporate office and takes control from the panicked toddler.
It's literal physical rehab for the mind. Like physical therapy for a torn ligament.
It is exactly like that. It takes time, it takes repetition, but the tissue heals.
And technology is actually starting to play a positive role here too, right? The report made a really sharp distinction between active tech and passive tech.
Yes, that's a crucial distinction for the future of treatment.
Because right now, most isolated people are just endlessly scrolling social media on their phones, which is passive.
Scrolling is biological poison for the chronically lonely. It massively triggers the brain's social comparison engine, showing you everyone else's seemingly perfect connected lives without providing a single drop of actual neurochemical connection.
It's like chugging salt water when you're dying of thirst.
Exactly. It makes the underlying conditions so much worse. But active tech is entirely different. Specifically, the report highlights these new digital communal spaces that rely heavily on spatial audio.
I've actually tried some of these spaces in VR. It's where you wear headphones and you hear people's voices relative to their actual position in a virtual room. Like if someone is standing on your left, their voice only comes in your left ear.
Right. And it turns out the human brain relies incredibly heavily on those subtle audio cues to determine biological presence.
Interesting.
If a human voice sounds like it is physically 3 feet to your left, the ancient, primitive parts of your brainstem register that as, okay, there is a physical human near me. I am currently with the tribe.
So it tricks the biology.
It soothes the DRN alarm in a profound way that a flat 2D video like a Zoom screen, where all the voices are mashed together and piped through the same center speaker, simply does not. A flat screen doesn't register as presence to the mammalian brain.
So these spatial audio spaces act as a sort of evolutionary hack.
They act as a safe bridge. They're obviously not a full replacement for a real in-person hug or sharing physical space. But for someone like Elias, who is completely housebound by his social anxiety, it's a way to start that crucial microdosing process from the absolute safety of his own living room.
It's just amazing to think that we actually have the tools, both the clinical protocols and the technology, to completely reverse this damage if we just start treating it with the right level of medical urgency.
That right there is the key word.
Urgency. Which brings me to the philosophical conclusion of this entire deep dive. We started this hour by saying that the scientific consensus has shifted and loneliness is now classified as a pathogen.
Yes.
But sitting here, listening to how the brain heals, maybe a much better, more accurate way to frame it, is that connection is a fundamental biological nutrient.
It is the core substrate of human biology.
Yeah.
We have been conditioned by modern culture to think of a rich social life as a luxury item. Something you do on a Friday night if you happen to have the extra energy and time after working all week.
Right, like a hobby.
But the hard biological data we've looked at today tells a completely different story. Connection is water. It is oxygen.
If you don't get enough of it, you die. Or at least vital parts of your brain literally die.
You biologically degrade. Your telomeres shorten, your DNA unravels, your brain shrinks, your immune system attacks itself. We are an obligatory gregarious species. We evolved to function as a linked network. We simply cannot survive as closed, isolated systems.
So looking out at the medical landscape in 2026, are we actually getting better at treating this? Is the system adapting?
I think the foundational awareness is finally there. The sheer fact that this massive report was funded and released by a major globally recognized medical institute is a huge, huge step forward.
It legitimizes it.
It does. We are finally starting to see doctors physically prescribe connection. We are seeing primary care physicians prescribe attendance at local community clubs alongside prescribing statins for high cholesterol.
That is just such a wild image to wrap your head around. A doctor saying, take 2 coffee dates with a friend and call me in the morning.
Essentially, yes. Because regular coffee dates lower systemic inflammation better than some expensive anti-inflammatory medications.
It really deeply reframes how we should all look at our own daily lives. I mean, just sitting here, I'm thinking about how many times I've canceled plans with good friends at the last minute just because I felt a little tired after work.
We all do it.
Not realizing that the isolation itself is actively contributing to the physical fatigue.
We have to start protecting our social health as fiercely and aggressively as we protect our physical health or our diets, because biologically speaking, they are the exact same thing.
Well, we have covered an absolutely massive amount of ground today. I mean, we went from the prehistoric savanna all the way down into the brainstem, through the leaky fortress of the blood-brain barrier, and out through the neutral face bias.
It is a full, complex journey.
And for those of you listening, if you want to dive even deeper into the hard science, the full 2026 report, The Psychology of Loneliness, is linked right down in the show notes. It is a heavy, dense read, but honestly, the fMRI diagrams alone are completely worth it.
I would also say, definitely check out the specific section on the vagus nerve if you have the time. We didn't even get a chance to touch on that today, but the data on how social vocal tones stimulate the vagus nerve is just fascinating.
Oh man, next time, we'll definitely have to do a whole body electric deep dive to cover that.
It's a deal.
But before we officially sign off today, I want to leave everyone listening with a final thought experiment based on exactly what we've discussed. We talked a lot today about social hunger.
Right.
Now, we all know that if we were walking down the street and we saw a person actively starving, someone who was skeletal, incredibly weak, clearly suffering from a caloric deficit, we would feel an immediate, overwhelming moral urgency to feed them.
Absolutely.
We wouldn't look at a starving person and blame them for being hungry. We wouldn't judge them for their suffering.
We would just act. We would help.
Right. But the reality is, right now, we are entirely surrounded by people who are suffering from severe social starvation. Their executive brains are actively atrophying, their physical bodies are inflamed and attacking themselves, their entire perception of reality is horribly distorted by fear.
Yes.
But because we can't physically see their ribs showing through their shirts, we so often judge them. We look at Elias and we call him weird, or distant, or difficult, or just a jerk.
We blame the victim of the famine for acting like they're starving.
Exactly. So in this new world of 2026, where we finally have the hard biological proof of what is happening inside their bodies, how does our personal and social responsibility change? Can we actually build a society that treats social isolation with the exact same life or death urgency as a physical famine?
That right there is the great challenge for the next decade of public health.
So check on your friends, everyone. Make the effort, especially the distant or difficult ones. They might just be starving.
Stay connected out there.
Thanks for joining us for another deep dive. I'll see you all in the next one.